Hello and welcome back to another episode of Math with Stone. Today we're going to be doing some factoring of polynomials. Specifically, we're going to be doing some perfect cubes and some factor by grouping, as well as all sorts of other factoring problems for that matter. So the first thing that you're going to experience right now is a perfect cube of a factor problem. So perfect cubes, both terms, there's only going to be two, are going to have to be a cube rootable thing. So x to the third is definitely cube rootable. 27 is also cube rootable. And here on number 2, 8 is cube rootable, and the 125 is cube rootable. So there are two formulas that I recommend that you use, and they are right here. There's one of them, and here's the other one, which will look almost the same. Right there, okay? So those are the two formulas that you're given. If there is a minus in between, you're going to use the minus formula. If there is a plus in between, you use the plus formula. When we get the a and the b, because those are the parts that matter, the a is going to be the cube root of x to the third. The b is going to be the cube root of 27. Notice I did not put negative 27. The formula will deal with that for me. Okay, so it's the cube root of just the number, 27. There are other people that would probably use only the plus formula, and then they would put the minus 27 in there. I find that just makes it more annoying. So here, you find out that a is going to be x, because cube root of x to the third is x. And the b, the cube root of 27, is going to be 3. So if we fill it in our a minus b formula, we got a minus b, which is going to be x minus 3. Then a squared would be x squared, because a is x. Then plus a times b. You could write x times 3, but it'd be a lot more humane to write 3x. 3 times x is 3x. And then plus b squared. Well, b squared is 3 squared. So 3 squared ends up being 9. And that is all we wrote for that problem. Okay? Next one, we got to do the cube root of 8x to the third, which the cube root of 8 is 2. And the cube root of x to the third power is x. So this is going to be our a. And then the cube root of 125, if you couldn't guess it, is 5. That is going to be our b. Because there's a plus in between, we use the plus formula. So we use a plus b, so that would be 2x plus 5. Now here's the part where people make a mistake. They end up just writing 2x squared. They do this. That is wrong. You need to put it in parentheses, because a squared plus a times b, that would be 2x times 5, and then plus 5 squared. So this one I'm doing in 2 steps, you may notice. So this is going to end up being 2x plus 5. 2 squared and x squared makes 4x squared. 2x times 5 makes 10, and there should be a minus here. I forgot to write it. I'm sorry. 10x. And then 5 squared is 25. Okay? So that is perfect cubes. They don't get much harder. Sometimes you see a variable on the 125 term, and that just means that you have to deal with that too. The other new factoring method that we're learning today is factor by grouping. Factor by grouping works best when there are 4 terms. Okay? Normally, they will be in the way and oriented in a way that is good for you, but sometimes you are allowed to rearrange them to make it work out for it. Factor by grouping will not always work. Perfect cubes, just like, they have to be cube rootable. Factor by grouping has to be a unique thing. Here, we group the first two, we group the second two together. When we group the first two, you ask yourself, what can I factor out, greatest common factor out of both of those? Well, they both can divide by 2. And they both can relinquish an x squared. So that is what I'm factoring out of that. So we divide both of these by a 2x squared, and that makes an x and a minus 3. And the next thing that I can divide by on the next grouping would be a 5. See how we got a 5x and a 15? They can both divide by 5. So I'm going to put a plus 5 because it's positive. And then I'm going to divide by x minus 3 here. Excuse me. Divide and get x minus 3 there. So if you've done it correctly, these parts right here will be identical, and they are. X minus 3 and x minus 3 is perfect. If they're not perfect, you are not able to factor by grouping, or maybe you should have factored out like a negative 5 instead of a positive 5. So that x minus 3 is one of your factors. You can write it first or you can write it second. The other factor is this part right here, the 2x squared and the 5. That would be the other factor, and that's the whole problem. The only thing you need to be wary of is sometimes 2x squared plus 5 can factor further, but it cannot in this case because it is not a cube root, perfect cube, or a perfect square. All right, moving on. Factor by grouping here. Group the first two, group the second two. We can take out an x squared from the first two. That would leave us with an x and a plus 4. We can take out a negative 3 from the next grouping, and that would leave us with an x and a plus 4. Notice how when I take out a negative 3, it makes an x plus 4, but if I took out a positive 3, it would have made an x minus 4. It would actually made a negative x minus 4, which would be not good. Okay, so that's why I took out a negative 3 there. We have x squared minus 3 as one factoring, and then we have x plus 4 as another factoring. This, again, is also as far as it will go because x squared minus 3 doesn't factor any further. If that was x squared minus 4, well, then by all means, we would have to factor further because x squared minus 4 is x plus 2 and x minus 2. It isn't. Unless you want to be fancy, you could write x minus the square root of 3, which is crazy. All right? So, here we go. Solving for the perfect cube and solving factor by grouping. So now we're solving these things, and then later on we're going to be combining all sorts of factoring techniques. So solving a perfect cube is annoying. It is very annoying, to say the least, because technically you could be lazy and you could be like, well, x to the third is equal to 8, x has to equal 2. That is one answer. There are also two imaginary complex answers in this problem because it's an x to the third. We should have more than just one answer, okay? So the other two answers are going to come from this part right here, whatever was remaining. So we have an x to the third minus 8. We have to use our a minus b, a squared plus ab plus b squared formula. We have a would equal 1 for right now. Later on, it's going to be different. So a is equal to 1 and b is equal to 2. So this would be x minus, I don't know why I said 1. It'd be 1x, excuse me. X minus 2, x squared plus 2x plus 4. Okay? So this explains why we have one answer is equal to 2, because the x minus 2 would equal 0, but we also have x squared plus 2x plus 4 is equal to 0, which does not factor. Okay, so there's a reason that we stop here with factoring, and that is because this is never factorable, which means that this part right here has to be solved with either the quadratic formula or completing the square. And for fun, I am going to complete the square because it actually is a little easier. Subtract the 4 over, then take half of 2. Half of 2 is 1, put it in parentheses squared, and then add the 1 squared to the other side. Again, you could use quadratic formula if you prefer. You get x plus 1 in parentheses squared is equal to negative 3, which we then square root both sides. You get x plus 1 equals plus or minus the square root of negative 3, which means x would equal negative 1 plus or minus I square root of 3, and x would equal 2, like we already found out. Okay? So, hopefully you don't have to solve many of the ones that are perfect cubes because there's always going to be an imaginary part that you have to use the quadratic formula or completing the square for. Factor by grouping, however, needs to equal 0 or some other equals. These are not as bad to necessarily solve. You group the first two, you group the second two, just like we did before. We can factor out a 2x squared from the first grouping, and you're left with x and then plus 2. And then the second grouping, we can factor out a negative 1, and you're left with an x and a plus 2. The difference is that this equals 0. So then we would have to set both our factors individually equal to 0, which our factors, again, are the common factor, and then the things in front, the 2x squared and the minus 1. We don't need to use the quadratic formula here because it's just 2x squared minus 1, so we can set that equal to 0. Add 1 divide by 2, and then you get x would equal plus or minus the square root of 1/2, which you could probably get away without rationalizing the denominator there. And from the other factor, x would equal -2. Okay? Combining all factoring techniques. Okay, so recognizing which factoring technique is best, we're going to be using old factoring techniques, the tic-tac-toe board or whatever factoring that you've been using, grouping, perfect cubes, perfect squares, everything. Okay, this first one, it has 3 terms. 3 terms typically means normal factoring techniques. So I'm going to do that. Even though it's x to the 6th, if it's 3 terms and you notice that it goes from like 4, then 2, then no x's, 6, then 3, then no x's, where it goes half of it. It went from x to the 6th to x to the 3rd, that halved it, and then it went away. Normally a normal factor technique. We need to figure out what multiplies to -5 but adds to 4. Well, there's only 2 things that multiply to 5, 1 and 5. In order to add to 4, it's going to have to be a +5 and a -1. And these are going to be x to the 3rds because we started with x to the 6th. X to the 3rd times x to the 3rd makes x to the 6th. Okay? From here, we could be potentially done. X to the 3rd plus 5, dead in the water. 5 is not a perfect cube. X to the 3rd minus 1, not done because it's a perfect cube. 1 is a perfect square and a perfect cubed. So the x to the 3rd plus 5 remains, but this x to the 3rd minus 1, your a would equal a single x, and your b would equal 1. So then we would have to use the a minus b formula, and you'd have x minus 1 with an x squared plus 1x plus 1 as the final factoring problem when you plug it into the a minus b formula. Factor by grouping for number 2. Why? Because it has 4 terms. 4 terms does not work with typical factoring methods. So group the first 2, group the second 2. This time it may need to be rearranged. We're going to see how it works out because this is all sorts of jumbleness right here. So the first 2 terms you can factor out an x squared, and you're left with x plus 5y. The next 2 terms you can factor out a -3 and a y squared. Because this one has a y squared and that one has a y to the 3rd. We factor that out and we end up with an x and a plus 5y. So luckily it didn't need to be rearranged. Every once in a while you're going to have to move some things around and then try grouping again to see what happens. So here we get x squared minus 3y as one factor, and then x plus 5y as the other. You cannot do anything with that, which I think you assumed that that could not be factored any further either. 3, you have a few options. It is technically a cube root problem because 64 is cube rootable and x to the 6th also cube rootable. So you could immediately go into your AB formula. All right? AB formula could do that immediately, but it's also coincidentally, this is the one problem that's not only a perfect cube, it's also a perfect square. If you do that, you end up with x to the 3rd minus 8 and x to the 3rd plus 8. And doing it with this method first ends up making the problem a little bit easier. Still not easy because we still have an AB formula for both of these. Okay? So a for both of these is 1x, and b for both of these is 2 because the cube root of 8 is 2. So this is going to be x minus 2, x squared plus 2x plus 4 for the first one. And then the next one, because the AB for the positive formula is a plus b, a squared minus ab plus b squared, it would be x plus 2, and then x squared minus 2x plus 4. And all of this nastiness would be the answer. All right? And if you started with the AB formula, it would still work out, but it would be a little bit more annoying to deal with. Number 4, our last problem, is an actual normal factoring problem. You do not have 4 terms, so you cannot really do factor by grouping. So we're just going to multiply these 2 together. 5 times 6 makes -30 x squared y squared technically. So what multiplies to -30 but adds to -13? Well, it's not 1 and 30. It is 2 and 15, however. Or is it 3 and 10? We got to be careful. Okay, so in order to multiply to negative 30, one of these numbers has to be negative. And if we make it negative 13, the negative 3 and the negative 10 would have to be negative. It's going to be the 2 and the 15 in this case. So this is going to be x minus 15 and x plus 2. Now I have oversimplified this. I have not wrote the y's yet. But remember, whenever we're multiplying the 5, we have to divide the 5 in this step. So this is going to be x minus 3 and 5x plus 2, which you may notice is still not correct because there's the y's here. This is what I call a forwards and backwards problem because see how it went x squared, x, no x's? Read it backwards, y squared, y, no y's. All right? So what that means is that you just have to throw in the y's here with it, and you get your little accordion problem, and you get the right answer. Let's make sure it kind of makes sense. 3y squared and 2y makes negative 6y squared. And then x times 5x makes 5x squared. If we kept foiling, we'd probably end up with a 13xy. Okay? That's going to do it for this one. Until next time, my friends, I will see y'all later. Bye.